We know charges interact with each other. Like charges repels and unlike charges attracts. In 1785, a French physicist named Augustin T. Coloumb was studying this interaction of charges. As he has put forward a law regarding the interaction of charges, and that law is famous in the name of Coulomb's law. Or in other ways, as we say, his studies have been put forward in the form of a law called as Coulomb's law. The unit of charge has been named as Coulomb in recognition for his work in the field of charges. According to Coulomb's law, the force of attraction or repulsion between two charges separated by a distance is directly proportional to the product of the charges and inversely proportional to the square of the distance between the charges. And let me explain it in blackboard. Let's go directly to the mathematical expression of Coulomb's law. Let there be two charges Q1 and Q2, the distance between the charges be R. As per the Coulomb's law, the force of attraction or repulsion between the charges is directly proportional to the product of the charges. In mathematical expression, we can write it as F is directly proportional to the product of charges Q1 into Q2. And Coulomb's law states that the force of attraction or repulsion is inversely proportional to the square of the distance between the charges. Here the square of the distance means 1 by r square. So F is directly proportional to 1 by r square. Combining these two, we can write it as F is directly proportional to Q1 Q2 by r square. And this proportionality can be replaced using a constant, and that equation can be written as F is equal to a constant K into Q1 Q2 by r square, where K is the proportionality constant and its value depends on the medium in which you are placing the charges and system of unit which you are adopting for measurements. By doing experiments, we will get the value of K as K is equal to 1 by 4 pi epsilon. This epsilon is the permittivity of the medium which is being used to place the charges. For free air, that is for vacuum, constant K becomes 1 by 4 pi epsilon 0, where the value of epsilon 0 is equal to 8.854 farad per meter. Hence, in free space, Coulomb's law can be written as F is equal to 1 by 4 pi epsilon 0 into Q1 Q2 by r square, where this epsilon 0 is called as permittivity of free space. By putting the value of pi and epsilon 0 in the equation, F is equal to almost equal to 9 into 10 raised to 9 into Q1 Q2 divided by r square. We have to have a small knowledge about another constant ratio called as relative permittivity. Relative permittivity of a medium is the ratio of permittivity of the medium to the permittivity of free space, which can be denoted using the letter epsilon r. Epsilon r is equal to epsilon by epsilon 0. This is a ratio and doesn't have any unit. Epsilon is equal to epsilon 0 epsilon r. As we know, the electrostatic force of attraction or repulsion between the charges according to Coulomb's law when they are placed in a vacuum is equal to, we will write it as F air is equal to 1 by 4 pi epsilon 0 into Q1 Q2 divided by r square. If we are placing the two charges in a medium instead of in free space, then we have to take the permittivity of the medium instead of permittivity of free space. So when the charges are placed in a medium instead of free space, we will modify the equation accordingly and we will get F medium is equal to 1 by 4 pi epsilon into Q1 Q2 by r square. Epsilon is equal to epsilon 0 into epsilon r, which can be written as 1 by 4 pi epsilon 0 into epsilon r into Q1 Q2 by r square. By taking out the epsilon r outside, the force of attraction or repulsion between the two charges placed in a medium having the permittivity E denoted by F medium is equal to 1 by 4 pi epsilon 0 into Q1 Q2 by r square divided by epsilon r. since epsilon is equal to epsilon r into epsilon. This is equal to F air divided by epsilon r. That means epsilon r is equal to F air divided by F medium. This is one of the application of Coulomb's law. If we can measure the force of attraction or repulsion between a charges which is placed in free air, and we will find the value of that force and we will denote it as F air. If the same charges are placed in a medium having the permittivity E at the same distance, and the force between the charges be F medium denoted by F MAD, then if we have to find the relative permittivity of the medium, epsilon r is equal to F air divided by F medium. That is, if we know the value of force between the two charges in air and the same force between the two charges when the charges are placed in a medium, the ratio of the two forces will be the relative permittivity of that particular medium. So, to find the relative permittivity of the medium, we need to find out the relative forces between when the charges are placed in the medium and when the charges are placed in the free space. Let me conclude this session. As per the Coulomb's law, the force of attraction or repulsion between the charges is directly proportional to the product of charges and inversely proportional to the square of the distance between the charges. And the force will decrease as the distance between the charges decreases to the square of the distance between the charges. In recognition to the work of Augustin de Coulomb, the unit of charge is named after the name Coulomb, and unit of charge is Coulomb. This is the fundamental basics of electrostatic. I'll be coming with another topic in the next video. Stay tuned. If some changes has to be made so that the video will be much better and it will be much more useful for you to understand the lesson more simply and more fundamentally, leave your comments and share if it's useful to you. I'm Srinath signing off from the video. Thank you. Thanks for watching the video.